This is for Year 12 methods, and it's a description between increasing and strictly increasing. Okay, let's say we have this function here that's drawn, and I've located 2 points on the function. One is where the stationary point is at A and f of A, and the other one is where a stationary point is at B and f of B. Increasing means where it has a positive gradient. Therefore, the derivative at a particular point is greater than 0. So this particular function f of x is increasing here because its gradient is positive, and here because its gradient is positive. Therefore, it's increasing when x is from negative infinity up to a but not including to a, and when x goes from b to infinity but not inclusive of b, because at a and at b the derivative is equal to 0. A function is said to be strictly increasing if between a and b f of a is less than f of b. So everywhere between here and here, if this is a and this is b, f of a, which is the y value, is less than f of b, therefore it's strictly increasing, all the way up to and including this point here. And from here all the way up to there, it's strictly increasing. So strictly increasing when x goes from negative infinity up to and inclusive of a, and from b up to inclusive of infinity, but inclusive of b, because it's strictly increasing at this point here, because if you take this is to be a and this to be b, f of a is less than f of b, therefore it's strictly increasing. Where is it decreasing? Okay, so it's decreasing when x is an element of a through to b, but not inclusive of a and not inclusive of b, because between here all the gradients are negative, but at b and at a the gradient is 0. But where is it strictly decreasing? X is an element from a through to b, but inclusive of a and inclusive of b, because on the endpoint, at this point here, f of a is bigger than f of b. Therefore, everywhere in between a and b, it's going to be strictly decreasing. Strictly decreasing refers to the y values. Therefore, we include the turning point. Increasing and decreasing refers to the gradient, so we don't include them.